This looks like a simple object. In fact, it even feels like a small, soft balloon. It deforms, it flattens, and it doesn't maintain a rigid geometry. And that's precisely the problem. Because I wanted to wind it with thread in a controlled, repeatable way, much faster than by hand. At first glance, winding a thread around a toroidal piece doesn't sound so complicated. But when that piece is soft and deformable, everything changes. You're no longer working with a stable geometry. The object compresses, changes shape, and makes it much harder to maintain consistency throughout the process. Doing this manually takes time, requires a lot of attention, and is also difficult to repeat exactly the same way every time. So I decided to build a machine to solve that problem. The idea was to transform a slow and very manual process into a more controlled, faster, and much clearer system to execute. But it wasn't just a matter of moving a motor. A solution had to be designed that could work with a soft toroid without losing functionality. Before you start working, there is important preparation. The parts must be assembled correctly, mechanical elements secured, the thread loaded, the toroid positioned, and the system prepared in the appropriate manner. This part may seem simple, but it actually defines a lot about the stability of the process. Because in machines like this, proper functioning doesn't depend solely on the code or the motor. It also depends on the setup. The machine combines several parts. On one hand, there's the mechanical structure, which supports and guides the process. On the other, there's the electronic system, where I control the operation with an Arduino Nano and organize the connections on a breadboard, also called a solderless protoboard. I also integrated the operating interface to switch between modes such as charging and winding, and to adjust the system's behavior during use. In other words, this machine exists right at the intersection of mechanical design, electronics, and programming. Beyond simply rolling up a torus, what I really like about this project is that it demonstrates something very characteristic of engineering. Taking an uncomfortable, non-obvious problem and turning it into a functional system. And if someone wanted to replicate it, that's also part of the goal of showing it like this. Not only to see it working, but also to understand how it's made, why it was designed this way, and what technical decisions are behind it. Because for me, sharing engineering isn't just about showing the final result. It's also about showing the process, the reasoning, and the iterations that made it possible.